Okay, this is section 4.3, an entire section devoted to the operation of division for polynomials. So, you are going to be using a familiar algorithm. An algorithm in math is just a process for getting something done. The division algorithm is something you learned in grade school and probably didn't like very much because you didn't really understand what you're doing. You just had to memorize the steps, right? Well, I'm not here to tell you why you do what you do. That's not what's going on. I need you to recall that division algorithm in great detail. So we're going to do a problem like you did in grade school. We're going to divide 24 into 689 to remind you the division process. This is what it looks like. We're going to divide 24 into 689. That would be the same thing as offering it to you this way. 689 over 24. That's the exact same problem. It's just that this one is written so that you can use that process algorithm. You with me? So it may be offered to you in the book like this, and this is what you would write. But these things are going to be polynomials in your work. I just wanted to remind you the details with numbers since you're familiar with them. So the first thing you do is what?
With the one on the right?
Yep.
You distribute the 24 and you
Right. It's the distribute is probably the wrong word, but what you said is how many times 24 go into? What's the first thing? Into 68. And then you generally guess at that. Just guess. Give me an idea based on the size of the numbers. Just guess.
48.
Pardon?
40 times.
It's got to be a single digit. How many times does 24 go into 68? Twice? Okay. If I do a 2 right here, then how you check that or how you write this down to see if you're correct is you take this number that you decided here times this. Right? To see if you get this. Yeah. So you take 2 times 24, and the process of that would be 2 times 4 is 8. And 2 times 2 is 4. So we get 48 here. Then what? Then you subtract 48 from 68? Yeah. Okay, now listen. I need you to change right here, at this point right here, I need you to change your thinking just slightly to make it fit with what we're going to do. It's not any different. Instead of saying subtract 48, think about this and see if this makes sense. What we're going to do is we're going to change the sign on 48 and add. And you're going, that's exactly the same thing. But I need you to think of this as changing the sign on 48 and then combining this with this. It's the same as subtraction, same result. But I don't want you to think of it as subtraction. I want you to think of it as adding 68 and negative 48. Is that okay? Yeah. And what do we get? 20. And then what? Bring the 9 down and it becomes 209. First of all, if this had turned out to be more than 24, what would you do? You'd change your mind on that, right? Try it again. Okay, but it wasn't more than 24, so that was a good thing to put up there. So now we bring the 9 straight down here and put it with this, and it becomes 209. And then we've got to guess, how many times does 24 go into 209? What do you think? 9, okay. So we put a 9 up here, and we take 9 times 4. You think it'll be 8? Okay. Everybody want to change it? You want to change it too, Amy? Yeah. Okay. Change it to 8. We take 8 times 4 is? 32, so I'll carry the 3. 8 times 2 is plus 3? 19. And then what new thought process have we got right here? We're going to do what? Change the sign and add. And we get 7. Yeah, it's going to be a 1 there. I mean, you borrow. It's going to be a 1. It's going to be a 17. And then you look up here, and there's nothing more to bring down, right? So what we do now is take, this is the remainder, but we're not going to write R17. What we do is we put this, over the 24, 17 over 24, and we add it on to the end. If this number had turned out, or if this thing had turned out negative, which it might with polynomials, then we would say minus here. Now, most people don't write 28 plus 17/24s. They write it like this. However, when you say this number, you say 28 and 17/24, and the operative word there is the and that we just glossed over, and means plus. When you do this with polynomials, you will put a plus sign here. Okay? Means this and this mean the same thing. It's just this is a little shorter, but they have exactly the same context, which is 28 whole things plus 17 24ths of another. That's the same thing as this. So you're going to put a plus sign in. Do y'all remember your process? Okay, here it goes. It's going to be fun. One thing I want to remind you of before I leave this. When you're trying to decide how many times 24 goes into 68, aren't you asking yourself, or is it conceivable that you're asking yourself, 24 times what is 68? Or close? Is that what you're asking? This number times what? And that's what you put here, gives you 68 or close. That's what we're going to be using. Those ideas. We're going to do it with polynomials. So here we go. That was to get your feet wet a little bit, get your toes wet, get you experiencing on the water. Now we're going to try and drown you. Here it goes. Here we go. Okay, so the very first example says, divide 2x to the fourth plus 3x squared plus 5x. So they're actually using words instead of an expression to tell you what they want you to do. Minus 1. We're going to divide that by this, which is going to sit out here. This is being divided by what comes last. Do you understand this? You see what I'm saying? It's again, understanding your own language. We're going to divide it by x squared plus 3x plus 2. Wow. Here we go. When we start to do this right here, we are working with only this term. We're going to ignore these. We're going to work with this biggest term here. It'd be like you working with the tens digit or the hundreds digit if you're dividing by hundreds. And this one, we're only going to work with those two at first. So try to get that in your head. You're going to ignore everything else. And the question you're going to ask first is, how many times does x squared go into 2x to the fourth? And that is such an obscure and strange and bizarre idea that most people don't understand what they're asking themselves. Instead, ask what I told you just before I erased that problem. Ask yourself, what do I need to multiply this by to get this? And 2. What do I have to multiply this little guy by to get this bigger guy? That's a better question. That's something most algebra kids can handle. And the answer is 2x squared, because 2x squared times x squared is 2x to the fourth. Now, when you've made that decision and you write down the result, remember what we did when we said with the when we were trying to divide it into 68, we had the 2, and then we took 2 times 24 and wrote it down here? Well, you got to take this times all of this and write it here. So this first term made the decision on what to put here. But when we do the next step, we take our decision and multiply it by the entire divisor and put it here, just like we did with long division. And it's going to be, since it's a distribution, it's going to be 2x to the fourth. And it had better be 2x to the fourth, otherwise you made that wrong choice. That one better, those two better match up. Then we take the 2x times that part, and that's going to be plus 6x cubed. You following? And then you take the 2x squared times 2, and you get plus 4x squared. Did I do something wrong here? If I put 4x squared here, can you see that if I were to put this together, these are not going to combine? I made this mistake on purpose so that hopefully it'll stick in your mind. What? If I were to change the signs and add, that's what I taught you to do. If I were to change the signs and add, these two would add out, but these won't add up because this is a square term, this is a cube term. You can't add them. No, we're not timesing.
Like the 2x squared and then the
2x squared times 3x is 6x cubed. And it's sitting under an x squared, and that's not going to work.
I think it's 3x.
If you switch it.
Was this 3x cubed?
Yeah.
Was it?
Yeah.
Does that say so in there?
Yeah.
Okay, so this one's cubed. Is this one squared? Okay, there's a problem still. So it's going to work out if I combine, when I do my change to sign and add business in just a minute. These are going to work out. I'll be able to do something with these, but I can't with these. Because x's and x squares don't combine. So what do? The answer is, the thing that you are dividing, if there are any powers missing, you have to build them in with a 0. What was it?
Zero's positive, I bet.
Plus 5x minus 1. So the very first thing you better check out on problems like this is to make sure the thing that you're dividing has all of its power, starting with the biggest one. We got a 4, 3, we were missing a 2, you've got to build it in, a 1, and a constant. You have to build it in. The same reason why when somebody says, how do you write 104? And you do not write it this way. Do you? You write it this way. Means you got to have a placeholder. Even if there are no tens values at all, you have to have a placeholder of 0. Same thing with polynomials. If there is a missing power on x, you have to build it in with a 0. Just like you do naming 104, you have to build zeros in for your tens. Same idea. Everybody okay? All right, so now things are okay. I took this times each one of these and I wrote them down here and notice that they line up. X to the fourths, x cubes, x squares. Things are good. Even though that's a 0, it's still okay. At least we got something to work with and there's a placeholder for it. Okay, then if you'll recall back to when we were working with the numbers, then what did we do? What did I teach you? What did I ask you to change your mind to at this point? Change the sign and add. In our case, it's change the signs and add. We have to distribute a negative all the way through here. So I want you to memorize this instead. As soon as you write down what this times this times this, and this times this is, when you write here, before you even draw your line, change the signs. All of them. Change the signs. That's the same as distributing a negative. And then add. That's the same thing as subtraction, but if you adopt the idea, change the sign and add, you're going to be a lot better off, because if people think subtract, people put the negative there, and that's the only place they put it. It belongs to the entire result. And since there's more than one term, it needs distributing. So memorize this. When you write this down, say, this is how I say it. Change the signs. And as I'm saying, change the signs in my mind. I'm changing the signs, and then I write and add. And that's when I draw the line. Right there. Then you combine. You just straight up add, because we've already changed these signs. Those had better add out, or you've made a poor choice here, and you got to go back. These first ones add out. These ones right here, now that we've changed the signs, adds up to negative 3x cubed. And these add up to negative 4x squared. Yeah? Then we bring down the next term, just like we brought down the 9 in the last problem, along with its sign.
But you don't bring down the one.
No, one at a time. If I were taking that 24 into thousands, I would only bring down the 9 and do that process, then I would bring the 1 after that and do that process. You only bring them down one at a time. After you brought that down, didn't we ask ourselves, how many times does 24 go into 209? Remember that? Now we're asking, how many times does this go into this? Just like with numbers. Only we will focus on this and this only. The question you're going to ask is, this times what will give me this? Negative 3x, that goes up here. Then we take that negative 3x times all of these and write them here. Negative 3x times x squared is negative 3x cubed. They had better turn out the same, or you made a poor choice. Negative 3x times positive 3x is negative 9x squared. And negative 3x times 2 is negative 6x. Then what? Change the signs and add. They better add out, and they do. This adds up to 5x squared plus 11x minus 1. We're bringing that last guy down. See it? Y'all clear? We ask the question again. How many times does this first one go into this one? And it's positive 5, right? Then we do this. We take that result, 5 times x squared, and write it here. And 5 times 3x and write it here. 5 times 2 and write it here. Then change the signs. And if you're not going to use your eraser, like I get to up here, it's pretty easy. I just use my fingers. Make sure you completely obliterate it. Don't just do this, because people miss that they changed that. Don't just color it in. I would obliterate it and write a minus, or use your eraser, which is even better. Okay? But make sure you understand what your sign changes are, and they can't be misinterpreted. Those had better add out, and they do. This adds up to negative 4x. This adds up to negative 11. Okay, so far? And then you might say, well, how many times does x squared go into 4x? And the answer is it doesn't. So you're at the remainder stage now. And you stick that remainder over the divisor and add it on. So let me show you 2 ways you could write this that I will accept for full credit, and show you the way big ideas will probably want you to do it. Plus, I'm going to just put plus, and then I'm going to make this thing negative 4x minus 11 and put it over x squared plus 3x plus 2, and I would accept that for full credit. However, this guy right here could have factored out a negative. And if you did that, then it would look like this. Which is the way big ideas may probably want it.
So you just factor out the negative.
In fact, yeah, I factored a negative because this was negative right here. Even if this were positive, I'd still factor out the negative so that my leading term right here could be positive. So pretend with me, just pretend that this was a positive 11. Then when I factor the negative out, this will become a negative 11, and I will have 4x minus 11 over that. But this will be a minus because I factored it clear out of the remainder. As it was like this. And I, personally, as a teacher, don't care whether you put them both negative and make this a plus. If you factor that negative out so that this is minus that. Big ideas might care is all I'm saying. Okay? Did you follow that?
Yeah.
Want to try one? Okay. Everybody needs to get a piece of scratch paper out and try this. And I am going to give you one of your exercise problems to do so that as you practice this, you will also be knocking out some of your homework. Is that right? So what I would like you to do is number 7 on page 177. And I need to make one comment before you dig in. It is not essential, but it is much, much easier if you also make sure that the thing you're dividing by has all of its powers as well. And if not, build a 0 in. Can you see why that's going to become important here? In number 7, you're dividing by x squared minus 1. You should put up here x squared plus 0x minus 1. It's helpful to have all your zeros built into this as well if you need to. So check your thing you're dividing and check the thing you're dividing by, and both of them had better have powers that march right on down. And if they don't, you build in missing terms with a 0. So give it a try. I'm sorry if you're viewing this, you might want to try this now too, because I'm not going to turn this off because I have to make 2 videos. So just hang tight, try to do number 7 based on what I just told you, and we'll come back here in a minute. But this is just going to keep on coasting through and recording. If you happen to be a subscriber that is not in my class, then I'm going to put the problem up here and you can practice it while these guys are practicing it. This is how it's written on number 7. Blake, you don't have are you working it out on there? Or do you need a pencil paper?
I have it open on big ideas.
Okay. Yeah. This, I understand. This is a pencil paper thing. You can't really get around it, so everybody should have that in hand and working on it. Hung up and you don't know where to proceed next, or if you're wondering if you're doing what's right, why ask me. That's why we're doing this. Let me come to your desk and see. Which is 0x squared. You just have to keep track of the x squared. There's just none of them. That's just a whole place, just like before. So that when you take this number times this and times this, the line up here. Because if you don't do that, you would get an x cubed term and an x term. And there would be nothing here. And you can do it without that. You have to remember what that's fucking like. It's just easier if you build them all in. You just make it x. Change your sign for this one. Change everybody's sign and add. The change of sign almost always doesn't matter. That's just a good habit, okay? But the other are important. Now, add those together. It's milk. Okay. You take x times x squared, and right here, that's x cubed on it. Then you take x squared times 0x, well, that's just 0. That's to hold the place. And so this is an x squared, this is just x squared. Erase that too. Because you've got an x squared, you get an x times 0. Then you take x times 0x and get 0x squared, just to hold its place. And then x times negative 1 is negative x. Then change all your signs and draw a line to add what you got so far. You else in the hand, get stuck watching it and doing it, a different thing. In case you're done and you want to know if you're right, I'll put the answer on the board, but I'm going to show you how to do it in a minute, but I'm not going to show you yet. Just use this just to check your answer. It is you keep working, and I'm going to start working on this because we haven't got a lot of time today. I'm going to put it up here. Don't look up here unless you absolutely must. Anybody need more time? Is that what you got? Cool. For your information, this is the only way to do division if your divisor, remember what your divisor is? Remember the terms, the thing you're dividing by? If your divisor is quadratic or worse, meaning a higher power than that, if the thing you're dividing by is a power 2 or higher, this is your only option. However, and this is the cool thing, and this happens way more often than this does, if your divisor is linear, like that, something like that. You understand linear when you see it? If the thing you're dividing by is linear, there's a far faster, more efficient, less paper, less mistakes, less time way of doing it than this. You can do it this way. You have only this option if this is squared. Please understand that. If your divisor is a quadratic, you have to do it this way. But if it's linear, you can use a process called synthetic division. What does synthetic mean? Fake or man-made as opposed to natural, something like that, right? So this is a division algorithm, means a method, that accomplishes the same thing as what I'm erasing in a fake way. But it comes out with the right answer if you know how to interpret what you've got. It's a much, much easier way, and you guys will like this once you practice once or twice. You're going to like it a lot better. If it's a linear type division, divisor. So I want to look at page 175 at the top, and I want to divide that cubed polynomial by x minus 3. And the thing we're dividing by is linear. Can someone read that to me so I don't have to keep coming back to my board? It's example 2, top of page 175. It says divide what? Negative? Anybody? Example 2, top of page 175. Negative x cubed, and then?
Negative x cubed plus 4x squared plus 9 by x minus 3.
This is the thing to note. X minus 3 is what we're dividing by, and it's linear. So what you have to do in order to, this is your first exposure to synthetic, and you're going, wow, I don't know if I like that, because it's new, you might not, but after practicing it once or twice, you will like it really well. So just stay with me while I'm trying to teach you. The first thing you have to do is decide what value of x makes this 0. And the answer is 3. You all agree? And then you put that 3, I say put it in the box. When I ask you questions about it, I say, what are you going to put in the box? And the answer is 3. And it's a box held out over here to keep it separate from the others. You can make it in an actual box if you want, but this is enough. And then, when you've decided what goes in the box, then you write down the coefficients. Only the coefficients. Remember what coefficients are?
The numbers.
Yeah, the numbers in front of the variables in all these terms. This coefficient is what? And this one is? And then the next one would be? 0. Got to watch for it here too. And then 9. That's the coefficient of the x to the 0 term. Remember, that's still x to the 0. We shall bother to write it. So the coefficient of this last term is itself. It's the constant. But this is missing an x term. And if you fail to put a 0 in for its place, for its coefficient, it's going to screw it all up. So what we do is after, right out to the side of this, we write down the coefficients, and we put enough space between them that we don't believe this one is 14. Like that. Put enough space that you understand that this one is separate from this one, because sometimes the coefficient will be 14. Then you want to cram them together. Do you understand what I'm saying? Mm-hmm. So give it enough space, spread them out a little bit, and then a 0, and then a 9.
You put a 0 because it's x squared.
No, because there's an x term missing. Remember the divisor thing I just taught you a few minutes ago? It's got to have a 3, a 2. It doesn't have a 1, so we need to build it in, and a 0, basically. Y'all following? Then, if you're doing this on line paper, then you skip a line, and you draw a line, so that there's space to write things here. And this is how you go about it. That's the setup. Instead of taking x minus 3, and then the big bar, and then all the x's and stuff, it's only about the numbers, only about the coefficients. And the first thing that you do, this is the process, I'm teaching you the algorithm. Bring this straight down to there without doing anything. Just drop that thing straight down. And then it begins. And it just keeps doing the same iteration over and over and over. Here goes, watch. You take the thing in the box, times this number below the line, and write it here. And add. Not subtract, add. Why not subtract? When you changed the sign on this, when you chose what makes this 0, you built in the change in sign for every process. It's really cool. So choosing what makes that divisor 0 and putting it here, you've already taken care of all the change the sign and add. The change the sign happened right here. Now we just add. So then we take this 3 times this result and write it here. And add. And then we take this 3 times this result and put it here and add. And when you're done, this thing is the remainder. And this thing is the resulting polynomial. And so we have to now put the x's back in. I want you to get used to this phrase. You're going to hear it over and over and over before this chapter's over. Every time you divide a cubed function by a linear function, you will depress the power of the result by 1. Because we're taking an x into x cubed, the result should be x squared. So we have depressed this from a cube to a quadratic, and these are its coefficients. So this is how you report the answer. Negative x squared, because we depressed it from a cube to a square, plus x plus 3 plus 18 over x minus 3. You see how you bring the x's back home to answer the question. You didn't deal with them here, you only dealt with numbers, which is cleaner, shorter, fewer mistakes, and less to drag around and make errors with. But you have to bring them back at the end because the answer is in terms of x. Follow that? Do you want to try one, or do you want me to demonstrate one more without all the explanation? Just go through it and show you what happens. Do you want to see one more, or are you ready to try one? Okay, let's do one more. I'm going to do one that isn't just an x something. The divisor isn't just x minus 3 or x plus 2 or something like that. I'm going to do it with something like 2x plus 5 or something. They may not make you do that in this section. I'm going to do it anyway just to show you what to do. I'm going to make one up. So do not look for this in your book. It's not there. This is one that I'm going to make up. So I'm going to do, this is how it's going to be, would it be phrased in the book, would be something like 3x to the 4th minus 2x cubed plus 7x minus 4 divided by 2x minus 3. Yeah, I think that'll be okay. We might run into a little bit of trouble here, but try to keep up with me on the arithmetic. So what shall I put in the box? You remember when you had factors of linear things and I said, what makes this 0? And I taught you that little rule, back over front opposite sign. Remember that? The value of x that makes this 0 is back over front opposite sign. Remember when we did factoring and I taught you that? No? If you factored a polynomial into two things like this, if you had 5x minus 2 times x plus 4 equals 0, you factored into that and you said, okay, well, I know what that one's going to be. It's going to be negative 4 because negative 4 and 4 is 0. Well, what's this one? Well, back over front, opposite sign. Remember that? Well, that's what it is because you're asking yourself 5x minus 2. When is that equal to 0? As soon as you kick the 2 over, there's your opposite sign. And you end up dividing by 5. So it always ends up being 2, this guy, over 5, opposite of that sign because you kicked it over. You with me? So when you're making that decision about your divisor, it's the same question. What makes this 0? 3 halves. What goes in the box? 3 halves. Are you with me? You see how you make that decision? Okay. And then we put these others in. We get 3. And make sure you separate it out so that it doesn't look like 3 minus 2. So we have a negative 2, a 7, and a negative 4. Right? Yeah. No! Oh. What should it be?
0.
Where?
After
the negative 2. People, you have to remember that. If you screw it all up, it doesn't happen all the time. And that's why people forget to do it because they're thinking, it didn't happen the last 3 questions, so my mind's relaxing. Don't ever do that. You've got to look. 3, negative 2, and then there's a squared term missing, then our linear term, and then our constant. Make sure you account for that because it'll mess it all up. Then we draw a line, leaving a space for the gaps, and here we go. We bring the 3 down, and we take 3 halves times 3. If you're not very good at that, you can ask your calculator. It's 9 halves, which is 4 1/2. 4 1/2 combined with negative 2 is negative 2 1/2. is 5 halves. You can ask your calculator these things. Then we take 3 halves times 5 halves, and that's 15 fourths. This is what I get for making up my own. This turned out really nasty, really fast. Then you take 3 halves times 15 halves, and that is 45 eighths. And at that point, you may want to grab your calculator. That'll be 56 eighths plus 45 eighths. It's 101 eighths, I think. Somebody want to check that out? $56 and 45 would be 90 and then 11, so I think it's 101. And then you take 3 halves times 101 eighths, and you get 303 sixteenths. 4 written as sixteenths would be 64 sixteenths, but it's negative. So I got 300 minus 64 would be 36. So 39, 239 sixteenths. This turned out really ugly, really fast. It's because I made it up. I'm sorry. But this is how you would handle it if it happened. And you'd use your calculator probably to do your fractional arithmetic. In any case, the answer would be, look at what we started with. What was the degree of the thing we started with? What will be the degree of our answer? 3. It always depresses it by 1 when you divide by a 1-powered divisor. It always depresses the degree of the polynomial by 1. So the answer to this would be 3. X to the 4th. I just said that. 3x to the 3rd plus 5 halves, x squared plus 15 fourths, x plus 101 eighths plus 239 sixteenths over 2x minus 3. Gross. That is horrible. You will not hit anything that hard on this exercise. That's because I made it up. I apologize. But that's still the process. Bring this down. This times this, put it here and add. This times this, put it here and add. This times this, put it here and add. Put this times this, put it here and add. And understand that your results, that's your remainder. And this stuff has been depressed by a power. So it's cute. If there are any zeros in this answer, you do not include them in your answer here. But you have to build in zeros to make it come out right if necessary. You want to try one? Sure. Okay. Here's another one that you can do to knock out a few things from your exercises. How about you do number 17? It's the worst one. If you can do that one, you'll be just fine. So do number 17 on page 177. And even though you're doing that one before these others, it's okay that you do that one next. I don't care that your exercises be in order, just that they are complete. So I'm going to erase this to see if you can do it without having to look up here. Besides that, it was gross. That example was horrible. Okay. So this is what's in the book. For anybody viewing this without a book, this is what they want us to do. If anybody needs any help, let me know. I'll be right there. Don't look up here unless you need to. Absolutely need to. I'm going to do it, but don't look up here to cheat with. Try it on your own. got one more thing to show you, and I'm running out of time. I gotta move on. Are you okay with this? Does anybody have any questions? What?
So how come it's a +1 instead of a +x?
Because this was cubed, squared, linear, this is x to the 0. This is your constant on the end. This is the remainder. There's no x on the last one because the end of any polynomial is a constant if it's not 0, right? And it depressed it by 1, so it's cubed, squared, linear, constant.
Yeah.
And then remainder. And the reason why it's minus here is because the remainder was negative, so I just made this a positive fraction but subtracted it. Everybody clear?
How come you made the 6 positive over on what you divided by, not the negative 6?
Because that's the value that makes this 0. 6 minus 6 is 0. So the value of x you put in the box is what makes this 0, which would be 6.
So when
In other words, the opposite.
when you take the negative out of, like, why don't you take it out of the bottom 2 so it's -x + 6 or something?
Because it's just a negative fraction. It's really this. But you know that a negative in a fraction can go anywhere. It can go here or here or here. But there's only one. There's only one. I just chose to bring it down here, the 1. Everybody okay?
Yeah.
All right, I got one more thing to show you. And while I'm erasing this, I'm going to tell you, sometimes you have tools in your toolbox that you use them, the very exact same tool, to accomplish different things. For example, and sometimes people use a wrench as a hammer because they don't want to go get the hammer. That's not what I mean. That's a poor use of it. However, I have a roofing hammer at home, and this year I had my front fence blow over. It's got the pickets, it's got the funny little shape at the top, the pickets, the fence made with the boards that are about 6 feet tall, and the pickets. And when I got it all set up, all level and everything, and ready to put the pickets on, the ground underneath was not even. And the end that I started on was lower than the end that I finished on. Not by much, but a little bit. And so I didn't want the pickets climbing up with the ground. So instead, I dug a little trench this wide as I went along, deep enough to set the picket down in so it would line up. You understand what I'm saying? Guess what I used to dig the trench? The claw side of my roofing hammer. It worked beautifully. And it wasn't a poor use of it. I mean, it wasn't like busting your wrench to try to pound a nail. You can't hit the nail well and you're swearing at the nail and all that kind of stuff. This worked beautifully. And the reason I say roofing hammer is because the claws on a roofing hammer just barely dig down like this. So you can grab that thing, the claws of that, and just tear up the ground fast, but not too much of it, just enough to put the picket in. So it was a great use of a hammer that wasn't used, that's not what a hammer is usually designed for, but it worked beautifully. So I used the exact same tool to accomplish 2 completely different tasks. Why do I bring that up? Because synthetic division is great for dividing. That's what it's designed for. But it can also be used to evaluate. There's a difference between dividing and evaluating, just like there's a difference between pounding nails and digging earth. Same tool, totally different projects. And you have got to separate in your mind what you're being asked to do. Synthetic division is your tool, but you will be accomplishing totally different things. So here's what I mean. If you look at example 4, I want you to notice how it is different. The way the problem is posed is different from what we've been doing. In example 4, it says, use synthetic division. It's like saying, use the hammer to dig up the turf. It's saying, use synthetic division to evaluate. Does not say use it to divide. You've got to get it in your head when you're looking at the instructions, how you're going to use this tool. It says to evaluate this third degree polynomial when x equals -4. It does not say divide by x plus 4. It says when x is -4. What do you put in the box? -4. You put the exact thing in the box that they want you to use synthetic to evaluate. You don't change the sign on that because it did not give you a binomial to divide by. It gave you a number to evaluate. So you put the number in the box when it says evaluate rather than divide. We're still going to use the tool synthetic division. So we're still going to put 5, -1, 13, and 29 out to the side. But we are evaluating, not dividing. Here we go. Bring the 5 down. -20, -21, -104. Is that right? -104. minus 14 would be 90, so what's that, 91? Is that right?
No, it's
It should
84,
be
97.
84 instead of 84.
Oh, 84? Here? Okay. And this turns into what?
97.
What?
It's a positive 97 and a positive.
Wait, don't leave me. Well, that was positive 84, right? This is 97? Hang on, there's just one more step. Negative 4 times 97 is what? What does it say? How much?
Negative
388.
Negative.
Okay, and what does this do? Negative 359. The answer, folks, is that. It's saying that if you put negative 4 into the x's of this cubed polynomial, this is. So when you're evaluating, none of this else matters, only this. And what it's saying is that f of negative 4, when you plug negative 4 in, you get negative 359. It's another way to evaluate.
And on that one, you don't have to change the.
No, you do not change the sign. You plug the value in that you want to put when you're using that tool that way. All right, try to have a good weekend. In spite of what I just said again.
It sounds like your motor.
Does anyone need the written assignment?
Thank you.
Okay, it's right here. Or you can get it on Big Ideas, either way. Who needs it? Okay, well, there it is. If anyone wants it. There you go. Have a great day. Bye.